Okay, we're live. Hello, this is Toby, and I've been very interested in fractal geometry lately, ever since having learned about the Mandelbrot set. And I'm currently reading a book called Introducing Fractal Geometry by Nigel Lesmoir-Gordon. I found a sort of an algorithm in the book which looked pretty interesting, so I'm going to try to implement it. There's actually quite a lot of fractals, quite a lot of algorithms for generating fractals. For example, you can generate this fern leaf, or just this fern, using a repeating algorithm. You can generate this fractal tree. Actually, I really want to try making these as well, maybe sometime in the future, but right now I want to try this randomized algorithm. So this is the description of the algorithm here. The algorithm was discovered by Michael Barnsley. Also I want to give a shout out to the fractal page on Wikipedia. Has a lot of great information there if you're interested in getting an introduction to fractals. And also this book that I'm reading is lendable on archive.org. So if you go to archive.org, look up the Introducing Fractal Geometry, you may be able to lend it. Okay. So let's look at this algorithm. So there's some simple rules you can follow. So you first draw 3 dots in a triangle. So you do start with a triangle. Like you get a piece of paper. In my case, I'm gonna do it in code, so I'll probably make a canvas, and then just put 3 dots, 1, 2, 3, and then you pick a 4th dot at random in somewhere within the triangle. So I guess I don't know how maybe I'll just generate a random dot anywhere within the canvas, and then if it's within the triangle, I will plot it there. I don't know, or maybe I can just pick. Yeah, maybe I'll just hard code what that is if I don't feel like trying to figure out how to do that. And then what you do is, oh gosh, I need to do some math now. I roll a die. I roll, oops, did not mean to do that. Okay, I roll a die and point. So when they said starting point, they're saying the 4th dot. The 4th dot, we're gonna have that be the starting point. That is the starting point, and they're saying if you get a 1, then you're gonna draw another dot halfway from the starting point to the first point. First point is point number 1. So you're gonna draw another point here, and you're gonna label it point number 5. But if the top face is either 3 or 4, then you draw another dot halfway from the starting point. Again, that's the starting point, to the second point, to here. So, which is what their picture has here. So draw another dot here. But there's more. If the top face is 5 or 6, then it should be halfway from the starting point to the 3rd point. But then, wait. So if you get a 5 or 6, 5, then you should do this. and that's point number 5. Okay, and then you repeat the process. So using your new dot as the starting point. So it seems like a pretty simple algorithm. I'll need to figure out the formula for finding the midpoint of 2 points. Oh god, I don't remember how that works. I guess I hope. Let me see if I can maybe work out the math here. I'm gonna try. So let's say this is the point 0, 0, which is not gonna be in the canvas. This is 0, 0. So this would be more like 0, 100. And let's say this is 100, 100. The midpoint would just be you average. Oops, I meant 100. I think you just average both of the x's and y's. Yeah, like, because you're trying to find the midpoint between here and here. So that's not too bad. Okay, that math should be not too difficult. It's just that I don't do math in my day job, so can get a little intimidated by math sometimes. But I think this is doable. I can probably get this working. Okay, I have a Yeoman generator for a very basic TypeScript based web app, so I'm gonna use that. It's called Airport YHTS Web. I usually use this when I'm prototyping simple ideas where I am not using a web framework like Angular or React. And then I have to npm install. I'm gonna double check the stream. Is it still going? Okay, the stream is good. Okay, waiting for the npm to install. Come on, you can do it, npm. We have to download TypeScript, and as we found out from my exercise of deleting the node modules folders from my computer, every time you install TypeScript, that actually eats up quite a bit of your disk space. So that's what we're doing. Okay, I think that worked, probably. I'm gonna use Atom to start coding, and I'm gonna use npm start to start up this web app. It tells me it's serving. Let me see. Okay, it worked. It worked. Great. I'm gonna do this side by side thing. Okay, so it worked. So this setup is basic. There's an index HTML file and a TypeScript file. And really, that's it. There's a webpack config and a TypeScript config. But those are not important because you don't usually need to look at them. I'm just going to delete this code, and I'm going to rename this to dice-based Sierpinski Triangle. I hope I spelled his name right. Okay, dice-based Sierpinski Triangle. I'm not even gonna bother. Maybe I'll make a canvas element with ID of canvas to make it super obvious. And while we're at it, might as well just give it a width and a height. Okay, let me see if that worked. Maybe also just give it a visual. So like, style equals, let's give it a border so we could kind of see it. Border 1 pixel solid black. See if that works. It works. Okay. Cool. Maybe make the width a little smaller so I can see where the border is. Maybe 450. Okay, that's good. Then, well, let's just do 400, 400. So it's an even number, and the math is a little easier. Cheats. Okay. Let's start coding then. So we got a canvas. I'm gonna grab the canvas using document.getElement by ID canvas. And I think to get a drawing context, I'll do CTX for short, as is customary. Get context 2D. I think this is how you do it. I have strict mode on. Actually, maybe just turn it off. Strict null checks false. It seems like strict null checks is already false. It's not called get context. What is it called? I totally forgot how to use that canvas. Get context. Just get context. What are you talking about? Oh, I have to tell it that it's a canvas. It's a HTML canvas element, I think, because otherwise it can't tell. I guess I have to like explicitly tell it that it's a canvas. Okay, I think we're good now. We can probably start painting things, drawing things. Fill rect. So this is 0, 0 in the corner here. So this is coordinate 0, 0, and this is coordinate 400, 400. So let's say we fill rect. We make a rectangle, maybe try to make a rectangle just as a setup check, a sanity check. And we're gonna do it at maybe 200, 200, no, 200, 200, 100, 100. To here is 300, 300. Let's draw a little square like that, and we're gonna need to supply the width and the height, which both of them should be 200, 200, and there it is. Okay, so we have canvas and we have drawing context. We can draw. Now let's do three dots to make this triangle. So let's say dot number 1 is just here, which is gonna be 200. This is 0, 0 those 0 in the x direction, but this is 200 in the x and 0. So this is, should be 200, 0. This guy should be 0 and then 400 here. And like we said, this is 400, 400. So in each of these points, I want to place a dot here. And to do a dot, I'll do a circle. Okay, so how do you do a circle? How do you do a circle in ellipsis? Canvas, draw a circle or draw a point or whatever. I have to use the arc method. Oh, come on. I don't want to do that, man. Is there an easy way to do this? I might have to use arc. Stroke correct. If I don't feel like it. Draw a triangle. Circle. I do have to use arc to do this. Good grief. Maybe I cheat. I'm thinking I cheat, and I'm just gonna use fill rect at that point. So what were the coordinates again? 200, 0. I'm gonna say width of 1 and height of 1. I'm gonna try to cheat. Yes, that's a dot. I see it. I don't think we need a very big dot. Do you see the dot? You may not see the dot, but there is a dot here. So I'm going to, I'm just gonna do that for drawing a dot. So this would be 0 and 400, and then 400, 400. So I should have the 3 dots drawn. You don't see these 2 though that are in the corner, but that's okay. Okay, so now I'm gonna follow this algorithm here. Oh wait, before that, I need to pick a starting point. I'm gonna make a dot function with an x and a y so that this code looks a little bit more obvious. So this code dot. Okay, so this should do the same thing. I think. Where's my? Okay, so this is. Let me pick a fourth dot, and for now, well, not. Yeah, I could change this later, but the starting point. Let me make a starting point. I'll have it in an array. I have x and y, and let's just say 200, 200. Doesn't matter. Starting point 0 and starting point 1. I'm using the zeroth, the first thing in the array as the x, and the second thing as y. So there's my starting point right in the center there. I could move it around, and I'm sorry, maybe I should see, there's the dot. Zoom in. There's the dot. There's a dot here. I think over time this will should I make a bigger dot for illustration purposes? Okay, let me make a bigger dot. I'm gonna do 3 and 3, and then I'm gonna make -1 from the x and y so that the dot is centered, looks more centered around the thing. Why did I open up the debugger? Totally did not mean to do that. All right, let's see. Okay, so you actually see a little bit of the point on the. So this is just so that you can see it a little bit better. Maybe make it even bigger than that. In case anyone is watching this, I want you to be able to see the dots. Okay, so that's the starting point. And to do one of these steps, we roll a dice. So how do you roll a dice? Well, there's a math.random function which gives you a number between 0 and 1. It's a real number. That's the algorithm. Okay, it's a real number, so I'm gonna multiply it by 6 and then math.floor it. At which point I should get a random number between 0 and 5. I'm gonna verify it just to make sure. I'm pretty sure that's right because I've done this times. So 2, 2, 1, 1, 0, 4, 4, 5, 4, 3, 5, 2, 0, 1. Okay, so that's my dice row, okay? It's gonna be a number between 0 and 5. And it's 0 indexed, which means I'm gonna use 0 to mean 1. So if the top face is 1 or 2, so if dice row is less than or equal to 1, so either 0 or 1, then I'm gonna draw a dot halfway from the starting point to the first point. Wait a minute. I'm gonna need variables first, second. So point 1 is the first point, let's say, which should be the one on the top. So maybe the dot function should just take the array. That'll make my code easier. So I'm gonna make the change to say the input of the dot. I'm using TypeScript and I'm not even defining the type. So I'll say this is an array. This is a point, and this will be. I'll just write here. Use the array spread operator. Not spread. The array deconstruct array. So this is, I'll say, let me define what a point is since we're using TypeScript. I'll say a point is an array of 2 members. Both of them are numbers. That's a point. So I will say this is a point, and I can use this deconstruction. Okay, it likes me now that I've wrote out the types for the input and output of the function, and then it also likes that x is a number and y is a number, because that's how I defined point to be. And also I guess it doesn't like that I have to explicitly tell it that starting point is a point. Okay, that's fine. I don't mind doing that. So let me have point 1, point 2. And point 3. 400, 400. And then I sort of change these calls to take in the array itself. To say if the dice row is less than 1, which means 0 or 1, then I need to find the midpoint between point 1 and the starting point. So I'll say new point is the average, which is going to be, you add the two things that divide by 2. So starting point 0 plus 0.10 divided by 2. Order of operations is important, so I have to add them before I divide by 2. So that's just the average of the x coordinates of between starting point and point 1. And we'll do the same thing for the y coordinate. To take the average of the 2, and that is our new point. And why don't we also dot? Dot is not a good name for this function. I think we should call it plot. Oh, I also have to explicitly say that it's a point. Okay. Did that work? Or no? I'm gonna console.log new point to see what. Oh, it could just be that we didn't get the dice roll we wanted. Oh, now we did. Okay. Yeah, because it's random, sometimes we don't get the dice roll we want. Okay, that's fine, but I think that code works. I'm gonna rename this guy to plot. And yeah, I'm just gonna rename it to plot. And I think I can rename all of the things at the same time and add them like that. Okay. So yeah, sometimes it'll draw a dot in between. The center one at the moment is the starting point, and then this top one is the first point here. Okay, so dot. So this is first point, second point, third point, and then this is starting point. But once you add a new point, then the new point becomes the starting point, I think. But I think you are supposed to update the labels of first, second, and third, probably. And actually, I don't quite know. It just says repeat the whole process after you do this. But are you gonna relabel? Are you gonna use 4 as the third point then? You're gonna do this big swap thing? I think, yeah, probably. It doesn't go into more detail about that, but I think you do. I think if you choose, this is my guess, is if you choose this point here, then you're gonna take and like you well, let's do step 1 first. So this is what I think. You're gonna you're either gonna get a new point here or here or here. So if you get a new point here, then this is your new starting point. Now if you never change what 1, 2, and 3 are, that means you're just gonna do it again, and maybe then this is your new starting point, and then this. I'm not sure if the labels should for 1, 2, and 3 need to change. It doesn't say that they need to change. I guess I'll just code the algorithm without making them change, because their notes didn't say that, even though intuitively I somehow think they should change. But anyway, I'm gonna not do that and just see what happens, and we'll do a bunch of iterations and see what's going on. Dice roll. I can't type dice roll for some reason. Okay, so else if it's less or equal to 3, which means it's 2 or 3, then I'm gonna do that to draw another dot halfway from the second point. So I do the same thing except to the not point 1 but point 2. Else I'm gonna do the same thing to point 3 instead of point 2. See if that works. I think. Okay, sometimes it goes here, sometimes it goes here, sometimes it should go, yeah. Sometimes it should go here. So, but I'm gonna change what the new starting point. We're gonna change the starting point to the new point. In all 3 cases. And loop. So while maybe just loop a number of times. I'm gonna make an counter started at 1 while counter is less than 100. I'm gonna do that. And then counter equals counter plus 1. Okay, let's see what happens. Oh, yeah, that does kind of look like a Sierpinski triangle. Let's do 1,000 then. Yeah, wow, that's actually very surprising how easy that was to achieve. Wow, 2,000, 10,000. Yeah, I'm gonna make my dots smaller now to get a more detailed triangle. I'll just go with width 1 and height 1. There we go. Ooh. Now maybe do 1,000,000. It may take a while to, but this already looks kind of good, I would say. My computer is crunching really hard. I wonder if that hurts the stream quality. Oh, yeah, that looks like a legit Sierpinski triangle. The downside is I have no idea how this works. Like, why does that work? Perhaps like, why did this work? Maybe to get an intuition of why this worked, we can go back and retrace its steps, retrace the steps of the algorithm. So what we can do, I'm gonna go back to the big dots so we can see the dots more clearly. And then I'll go back to fewer steps. Let's go with 10 steps, okay? It's hard to tell what's going on at 10 steps. So or maybe what we can do is, instead of doing this in a while loop, I have a button. Yes, let's make a button right under this canvas. I'll say step. I'll call this button step. Each time I click the button, it'll do another step. That's the idea. Step button. So in my code here, I will get a reference to the button element. Step button. And then I will add an event handler. Add event listener. Yeah, coding. This is what that's like. Okay, add event listener. So this callback will get called every time the button is clicked. And instead of doing all of this in a while loop, I'm going to move this in. I'm gonna stick it in a step function. And instead of just doing the loop counter thing, I'll just call step inside of the click handler. So let's try that. So step 1, we can see this guy making a dot here. Step 2, it's making a dot here. It's still using the same 3 dots as the anchor points. It's just another but using a different starting point. Using this, okay, let me go back. So initially this is the starting point, okay? And based on what the random dice, which is like there's a 1/3 probability that the dot can go here or here or here. 1/3 probability. So if you step, okay, it went here. But once you iterate once, this guy becomes the new starting point. So now there's 1/3 probability that it could go to the midpoint between the new starting point and 1. So it could either go here or here or here. Okay, the next time you step, it ended up going with that one, and this time this is the new starting point. So now this is the new starting point, and there's 1/3 probability of it going here or here or here. It's still hard for me to visualize why this process generates a Sierpinski triangle. And now we pick this point, and then the next point is going to be here or here or here. We pick this one. Now the next point is going to be here or even closer to here or here. It picked this one. The next one is going to be around here or here or here. Okay, it picked this one, so next one is going to be here, here or here. I can see that sometimes if it multiple times it shows the same point, like multiple times it shows point 3, it'll come closer and closer to that point, but eventually it will jump in a different direction because of the randomness. See, it just jumped twice towards point number 2, again towards point number 2, but this time it jumped towards point number 1. It went here, and then this time it went back towards point number 3. It kept going towards point number 3 and then jumping back. Now, why does this work? It's hard for me to see the intuition of how this thing works. Okay, maybe I'll read more about this, see if I can learn the reasoning behind why this algorithm works and creates a Sierpinski triangle. But I'm gonna click enough times. I'll do it have to do it maybe hundreds of times before it starts looking like it. Okay, in any case, I think I'll stop here, and if there's any one of you watching, thank you for watching, and I will see you soon.